During the first wave of space exploration, the first planet that mankind visited was our neighbor Venus in 1962. After that was Mars in 1965, then Jupiter in 1973. It wasn't until 1974 that Mercury was explored. Considering Mercury can get so close to Earth at times, you would think that it would be one of the first planets that we'd attempt to visit when Mercury is at its closest point to Earth. Astronomers call this opposition from the viewpoint of Mercury. This would happen when Mercury was at its furthest from the Sun and Earth is at its closest. When this happens, Mercury and Earth would be separated by only 77 million kilometers or 48 million miles. For comparison, Jupiter is 588 million kilometers or 496.76 million miles from Earth. That is almost 8 times the distance from Earth to Mercury. What's more unsettling is that Jupiter has been visited on a number of occasions, once in 1974, twice in 1979, 1992, 1995, 2000, and 2007. Multiple missions were launched to explore the likes of Saturn, Uranus, and Neptune. We've even branched out to visit things like comets and asteroids. But Mercury? Nothing for over 30 years. Why? Surely it can't be that uninteresting. Does Mercury hold no further secrets for us to uncover? No. In fact, the first and only mission to Mercury was a flyby, and it only managed to map around 45% of the surface. Difficulties of Mercury. The real reason we didn't go back is because Mercury is one of the hardest planets to visit in the solar system. It lives in an oven. Because of how close it is to the Sun, its surface temperature reaches highs of 430 degrees Celsius. Any probe that would visit it would need very high heat resistance. Remember, it's always a lot easier to warm things up rather than cool them down. The amount of engineering that would go into that probe would rival even our most state-of-the-art technology. More than that, because of its proximity to the Sun, any probe launched towards it would accelerate faster and faster due to the immense gravitational pull of our star. The sheer amount of energy and fuel that would have to go into safely landing a probe on Mercury's surface would be like swimming up whitewater rapids. Fighting off the gravity of the Sun to get a probe into the orbit of Mercury with the fuel capacity of a Discovery-class spacecraft would be like asking a child to lift weights with a rock. It simply seemed impossible. One of the unavoidable limitations of a spacecraft is its weight. It's a fine balance between the size and weight of a craft and the size of the rocket needed for its launch. The heavier the craft, the larger the rocket needs to be. The larger the rocket, the more expensive everything else becomes. To mitigate this, scientists and engineers try to keep everything as light as possible. Even fuel is included in the calculations of the weight of a craft. It's a double-edged sword in a sense, because more of it means more power, also more weight, which means it needs more power. See what I'm going with this? For argument's sake, let's say that an aircraft is allowed to be 100 pounds and it needs 60 pounds of fuel to operate. Well, that means the 60 pounds put aside for fuel alone is 60 pounds of scientific instruments that we can't put on the craft. Fuel takes up precious weight allocation, but it's also the most necessary part of any space exploration. So cameras and any other scientific instruments have to take a backseat in design. Considering all of this, engineers have struggled to come up with a feasible design for any Mercury-based spacecraft. So, for the past 30 years after Mariner 10's successful flyby of Mercury in 1974-1975, all Mercury exploration was put on hold. The solution. A trip to Mercury seemed hopeless. Hopeless until 1985, when an orbital mechanic named Chen Wan-yen figured out a way of getting a probe into the orbit of Mercury that didn't require a brand new feat of engineering genius. Instead, she worked out a particular route an orbiter could take around the solar system that would slow down enough through natural means with only minimal course correction. The only catch is that instead of going straight to Mercury, this craft would have to take the scenic route. According to Chen Wan-yen's model, a craft would need to orbit the Sun 15 times, fly past Earth once, Venus twice, and Mercury 3 times before finally slowing down enough to enter its orbit on the 4th pass. Essentially, These planetary flybys would skim the planet's atmosphere and shave off vital amounts of speed with atmospheric drag. Although, like I said, this is the scenic route. In its entirety, the entire route would cover 7.9 billion kilometers or 4.9 billion miles. It would take 6.5 years for us to land a probe on our closest neighbor, but it would be entirely necessary. While her findings weren't immediately picked up till 1998, NASA began to take an interest in the idea after realizing it was a feasible route. In 2004, they launched the MESSENGER probe. The MESSENGER standing for Mercury Surface Space Environment, Geochemistry, and Ranging Probe. A little wordy, but a cool acronym nonetheless. MESSENGER. The MESSENGER is only 1.8 meters long and 1.3 meter wide. Weighing in at 1,100 kilograms, it is considered very small in comparison to other NASA probes. The probe is equipped with a powerful thruster, a ceramic heat shield, 2 solar panels, and a whole suite of scientific equipment for imaging and measuring data from Mercury. Scientists had hoped to take advantage of this opportunity to learn as much as they could about the chemical composition of Mercury's surface, its geological history, its magnetic field, and its core, among other things. After its launch, it spent its first year taking a lap around the Sun before meeting back up with Earth. When it did this, it gave scientists a chance to test its equipment on a known astronomical body, us. They had to make sure that there weren't any errors and to make the necessary adjustments and calibrations. The probe took some photos of Earth and the Moon, as well as tested its ability to take readings of our atmosphere and magnetosphere. Fortunately, everything worked perfectly as intended. As it began to head further sunward, scientists employed a clever technique to help reduce its acceleration towards the Sun. It used its solar panels to catch solar radiation, like sails on a ship might catch wind. You see, solar radiation that hits an object actually pushes it very slightly. The force is very minuscule, but because MESSENGER's journey was so long, it really began to add up. Making the most of this phenomenon was one of the ways it also managed to save propellant and decelerate naturally. The landmark in MESSENGER's journey came in 2006, when it did its first flyby of Venus. Unfortunately, this also happened to be when Venus was at the exact opposite side of the Sun to Earth, which meant that we could not communicate with MESSENGER, thus no science was performed. At the very least, it did manage to take some photos that we later received. Luckily, MESSENGER had to pass Venus more than just once. In 2007, it passed Venus again, this time within radio contact and a friend to boot. The ESA spacecraft, the Venus Express, was also orbiting Venus at the time. With 2 spacecrafts orbiting Venus, the MESSENGER and the Venus Express performed the first ever simultaneous measurements of the particle and field characteristics of the planet. It was considered a milestone in the scientific community. But let's not forget what the main course was: Mercury. MESSENGER made its flyby of Mercury on the 14th of January 2008, and everything was going smoothly. The second flyby came and went, but it was on the third flyby in 2009 that drama struck. MESSENGER went into safe mode, which was designed to protect the system on the craft in the event of an error. It remained in safe mode for what must have been the most stressful 7 hours of all some scientists' lives. What had happened was, MESSENGER had to pass through Mercury's shadow during its flyby, meaning it had to rely on its batteries for 18 minutes. Unfortunately, something wasn't configured right in the power management software, a massive blunder for those involved. Fortunately, MESSENGER's computers did reset once power from the panels charged the batteries again. It managed to continue its mission and swing around the Sun once more before finally entering Mercury's orbit on March 11, 2011. MESSENGER took an elliptical orbit around Mercury, alternating between as close as 200 kilometers and as far as 15,000 kilometers. This is because Mercury acts like a giant sun mirror, radiating heat back into space. Staying too close to Mercury would have been too hot for MESSENGER, even with its heat shield. Moving further away every 12 hours gave it a chance to cool off. Once in orbit, Messenger performed above and beyond what scientists had hoped. It spent the next 4 years in Mercury's orbit, far exceeding scientists' hopes and expectations for the mission. Originally, they had planned for it to only last 1 year. More so, before launch, scientists had hoped that it would take at least 1,000 photos over the course of its lifetime. It ended up taking over 200,000. Messenger gave us a complete map of Mercury's surface in high resolution and color, as well as taking great photos of nearby comets and other planets. Messenger was a complete success. All good things must come to an end. On the 25th of December 2014, Messenger's propellant was finally about to run out. By this point, Messenger was orbiting a mere 25 kilometers from the surface of the planet. Scientists gave the thrusters one last burst to extend its orbit for as long as possible. But on April 30th, 2015, Messenger crashed into the surface of Mercury, and its long journey had finally come to an end. Messenger may be dead, but we're not done with Mercury just yet. In 2025, the ESA JAXA mission will arrive at Mercury, taking over the reins from NASA. There are claims that this current spacecraft is one of the most complex scientific missions ever launched. This single spacecraft will split into 2 spacecraft upon arrival at Mercury. Only time will tell what more we can discover from our small rocky neighbor. For now, we only dare to dream the impossible. Perhaps another Shen 1 will solve the puzzle to landing on this planet. And perhaps we're only a few years away from yet another triumphant Messenger mission. What more will we discover? With the launch of the James Webb Space Telescope, Mercury is not the only thing on the to-do list for the future. Check out our other video on the JWST to learn more. Stay tuned and come discover the infinite beyond with us.